Now you can switch off your cameras. Today is 25th of September and I welcome all curious minds for today's session. In this session, I will try to demonstrate, we will try to demonstrate, in fact, with me, Sumit Bobde sir and Yogesh Dudurkar sir will be demonstrating you enchanting phenomena associated with light. And this particular session will excite you about the topic that is light. You can use the chat box for your queries, but I want you to write down your queries in your notebook and write down the important points which I will be telling you in this session, right? So let us start the journey with the term L-I-G-H-T, light. What do we understand by the term light? Since the day one, when we have opened our eyes, what do we see? Whatever we could see is because of light, But the question is, can we see light? Can we see light? Use the chat box to communicate me. Can we see light? Yes or no? Use the chat box quickly. Yes, I can see your replies. Very good. So most of you are saying that we cannot see light, right? But we do observe something. We do see something. What are those? Those are the phenomena associated with light. So we cannot see light, but we can see the different phenomena of light. And we will try to demonstrate those phenomena today in this session, right? So when we see something, look at the wall of your room, observe it, look at the wall. You cannot see light, but you can say that the room is lit. This is because of some phenomena, The very first phenomena I am talking about is the scattering of light. Because of which the sky looks blue. Right? So what is this scattering of light? We'll try to see few demonstrations. In our demonstration room, we have the different sources of light. One of the source of light, which is known to you also, is laser light. So spotlight in the laboratory. So let us try to see laser light in our demonstration room. This is a laser torch. Observe it. Observe this torch, right? When the hands are moving, something is coming on the hands, onto the hands, right? Can we see the rays of laser anywhere? Can we see the rays of laser anywhere? Answer is no. In between, we cannot see anything. We can see just on the target that something is getting lit up. But in between, we cannot see the things. But when the same laser beam will be passed through a material, and the material is a glass slab with us. See, this is a glass slab. When the same laser beam will be passed through a glass slab, then you can trace the path of the light, isn't it? Isn't this enchanting? Same laser light. When this will be passed through a glass slab, you can trace the path of that laser beam, right? Keep that glass slab down again and switch on the laser. Why isn't this possible? Why it's not possible? Keep your hand steady. Keep your hand steady. Yes, yes. Can we see the path in between? So put your fingers in between, Yogesh. I want you to put your fingers in between the path of the laser beam. Yes, yes, yes. Now see, laser beam will get will show some effects when we'll put our fingers in between. Now we'll see the magic. We'll see the magic. Now you will see the same laser will give you the path without glass slab. Without glass slab. Lit it without glass slab. So let's count. 1, 2, 3. Yes, yes, yes. It has in air. In air. I want you to do it in air. Don't use any medium. Right. So I'm reading your inquiries also in between. Because light needs medium. Some of you are saying because light needs medium, because it is opaque. These are some answers I am getting. Okay, the pass through the box in which the air is filled. Pass through the box. Yes. See the beam of laser when it is passed through a box. A box. Right. So this effect is because of the scattering of light. Because of the scattering of light. Same kind of beams you must have observed at your home. If you have seen some beam from your window falling on the floor, you must have observed that you can see that beam because of the dust particles, because of the dust particles. So whenever light will interact with the dust particles, those dust particles will scatter the beam. And because of that scattering, we can observe the things. We can observe the thing. So this is about scattering. Let's move ahead. The next, we'll discuss the different properties of light. As I have said that what is light? So earlier light was thought to be consist of particles. Those particles were termed as corpuscles. Corpuscles by the great scientist Newton. And he came up with the theory called as Newton's corpuscular theory. But some of the phenomena of light was not found to be valid, could not be, means scientists could not able to digest those laws of Newton's when Newton was claiming that the light is some particles, some corpuscle. So scientists, researchers during that period said that light is not a particle. Light is a wave. Light is a wave. And they could able to explain few phenomena of light by treating light as a wave, And they claim that light is an electromagnetic wave in which electric field and magnetic fields are oscillating in the plane perpendicular to each other. Electric field is vibrating like this, magnetic field is vibrating like this, and the whole wave is moving in the third perpendicular direction. Electric field vibration, magnetic field vibration, and the whole wave is moving in the third perpendicular direction. And the wave moves with the velocity 3 into 10 to the power 8 meter per second. This is what the velocity of light which they could able to calculate during that time. So light was found to be particle by Newton, by Huygens and all. They claim that light is nothing but wave, which shows the different phenomena. They explained the different phenomena of light by treating light as a wave. And the important property is light can travel in vacuum. Light can also travel in vacuum. Sound cannot travel in vacuum, but light can travel in vacuum. So for light, what are the important points? Light is electromagnetic wave, which travels in air or in vacuum with the velocity 3 into 10 to the power 8 meter per second. This is something which is the information part of light. Later on, few scientists claim that there are some more phenomena observed in light which cannot be explained by treating light as wave, And they claim that no, light should have particles, then only one can explain this phenomena. So there was a war between the two group of scientists. And later on, they accepted that let's treat light as particle as well as waves, Few phenomena can be explained by treating light as a particle, and those particles were called as photons. They termed those particles as photons, P-H-O-T-O-N-S, which moves in free air, which moves in the space with the velocity 3 into 10 to the power 8 meter per second. Right? So let us demonstrate more phenomena of light which we experience in our day-to-day life. The very common phenomena known to you is reflection. So let us see what do we mean by reflection. Yes, Yogesh. Here you can see there is a mirror. When a laser beam hits that mirror at some angle, the same beam gets bounced back at the same angle. So the incident beam gets bounced back off that mirror at the same angle. Angle made by incident beam, with a normal. There is a normal. You can see the scale through which we measure the angle of incidence. Show the angle of incidence. What is the angle of incidence? Angle of incidence is this angle. The angle made by incident beam with the normal is angle of incidence, and the angle made by reflected beam with normal is angle of reflection. This angle of incidence must be equal to angle of reflection. This is one of the laws are something which cannot be proved, which can only be experienced. Law is something which is there from the God. Yes, this should happen. Right? So angle of incidence is equal to angle of reflection. You can see when you will change the angle of incidence, you can see the same change in the angle of reflection. Right? It can be easily observed with this setup. Right? And you can measure the angle of incidence and angle of reflection. Next is incident ray, normal, and reflected ray. All three rays lies in a single plane. It will not happen that incident ray will come like this. Incident ray will come like this and it will go to some other plane like this. Right? So incident ray, normal, and reflected ray lies in the same plane. Same plane. This is what do we mean by laws of reflection. Right? So next phenomena is total internal reflection. So what is total internal reflection? Total internal reflection is the complete reflection of light in the same medium. In the same medium. So let us see what do we mean by total internal reflection. Yes, demonstration please. This is a glass slab, right? Can you lit up the things from the top so that they can see what kind of glass slab this is? Switch on the torch. Yes, yes. This is a glass slab. Thank you very much. This is a glass slab through which will pass the light. Yes, yes, yes. Perfect. Through this, if the light will be passed at some certain angle, then see what will happen. See, if the light will be passed at some angle, then you can see that light will get reflected inside that medium. You can see the multiple reflections on the faces of the glass slab, right? So there is a certain fixed angle at which this complete reflection can be observed. And this phenomena is called as total internal reflection. And because of this phenomena, we are enjoying 5G network by Reliance today, because they are using optical fibers, and optical fibers work on this phenomenon. Total internal reflection. They pass on the signal and that signal gets reflected internally only. With the minimum loss of the signal, it reaches to the end user. It reaches to the end user. Can you show the complete length of that glass slab? Yes, so that they can see that the complete reflection. Yes, yes. So you can see that light is traveling with the total internal reflection, right? So this is again one of the phenomena which one can observe, right? And we are enjoying the facilities because of such phenomena only, right? Scientists are trying hard to know more and more about the hidden things, and they are taking those things out, and we are getting facilitated through those, right? Next phenomena I want to talk about is dispersion of light. Dispersion. Dispersion. You should write it down, right? All those phenomena. Dispersion of light. We know that light there are various colors of light, isn't it? White light, blue light, green light. Have you seen black light? Have you ever seen black light? Chat box, chat box. No, no. Good. So we can see various colors, right? Various colors. And that's why we are enjoying this colorful world, because of these colors. So white light is made up of all colors. White light consists of all colors. If something can absorb all colors, it looks black. It looks black. If some material can reflect all colors, it looks white. It looks white. So these colors represent one of the property of the light. It represents wavelength of the electromagnetic wave. Each and every value will give you some different color of light. The electromagnetic waves which we deal with light have the different values of wavelengths ranging from 400 nanometer to 700 nanometer. 400 nanometer to 700 nanometer. 400 nanometer to 700 nanometer. Below 400 nanometer, there are the waves whose wavelength is less and whose energy is higher than that of visible light. Those waves are called as ultraviolet rays. Those waves are called as ultraviolet rays. And the rays which have the wavelength more than 700 nanometer are called as infrared rays. Those rays we cannot see from our eyes. We cannot see from our eyes, but there are certain detectors through which we can detect those electromagnetic waves. So electromagnetic waves are of different kinds, and one of the kind of electromagnetic waves are the visible light, which we can observe through our eyes, right? All these are the informations. These informations must be there with you, but try to understand the importance of electromagnetic waves. So electromagnetic wave of wavelength 400 nanometer will have different color than that of electromagnetic wave of wavelength 410 nanometer, and which will be different than that of 500 nanometers, and so on. So each and every wavelength of light will give you different color of light, different color of light. So the color of light represents wavelength, and when we will mix all those colors, then we see white. So I want you to spin the top with the lit. Spin the top with the lit. I am taking Sumit, you on spotlight. Please lit and spin the top. Lit it. Spin the top first. Yes. Can you spin the top, the top which you have with you? This we'll see later. This will see later. So you can show the top is having all colors at the top. Yes. So this is a top which consists of all beautiful colors starting from red to violet. Yes. When we'll spin it, then see the color which it shows. So it is giving whitish appearance. It is giving whitish appearance. Right. Now I want you to shine the light over the CD. compact disc. Yes. Shine the same light, same white light on the compact disc. So this is a compact disc. You can see the beautiful colors which we can see on this disc. So they are lighting this disc with the white light, and you can observe the colors of rainbows here. Colors of rainbow, right? Starting from red. Can you observe it? Yes, yes, we can. Right? Means white light is made up of 7 different colors, you can say. Not 7, all colors, mixtures of all wavelengths of light. And those wavelengths of light can be separated by using certain device, certain instruments, certain optical instruments. And all of you can witness this. All of you must have experienced this colorful world of compact disc, DVD. So these DVDs are capable of splitting white light into its different components. Isn't it? So this is one of the instruments through which we can separate out the light. Other instrument, optical instrument is also known to you, that is prism. Prism. So prism is again a optical instrument. This is an optical instrument through which we can observe the phenomena of dispersion, in which when we'll project the white light over its faces, then on the screen you can see that yes, it will show you different colors. Those are diffused right now, but still you can feel the violetness and redness at the end. So this prism is capable of splitting those components of white light into different wavelengths. So this phenomena of light is called as dispersion. Dispersion. We can disperse the light into its different components, right? But there are different phenomena through which we can disperse the light. The phenomena which is responsible for dispersing light in CD is different than that of this prism. This prism. Prism is known to show one more property of light that we call as refraction. Refraction. What is refraction? Refraction is bending of light. Refraction is bending of light when it passes through a transparent medium. When it passes through a transparent medium. So light will bend when it will change the medium, when it will move from air to some other things in which it can travel, which permits it to travel, then it will change the direction. And this phenomena is called as refraction of light. This phenomena is called as refraction of light. Because of this phenomena, you observe the twinkling of stars. You observe the bending of pencil or your pen when you will put your pen inside a glass filled with water. Glass filled with water. Right? So we'll see this bending in prism. Can you project it? Yes, sir. So we are passing a beam of light through a slit across the edge of the prism. So this is a slit which will allow a parallel beam of light to pass through it. You can see a beam which is going through this edge of the prism. Yes, it's a nice view. And can you show the path of refracted beam? I can only see the path of incident beam. Yes, this is a screen. Yes, project it from different direction, opposite direction. Yes, yes. So this is the incident beam which is getting passed through the prism. It's a straight, and you can show the light is getting incident over that screen, means light is bending towards that screen. That bending is because of the refraction of light. At the same time, one can observe the phenomena of dispersion, but this bending is because of the prism, because of the material of the prism. So the material, that the content is responsible for the amount of bending in the prism. So in the dispersion, you can observe that when light gets dispersed, it will give you Vibgyor, Vibgyor, V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, R for red. It will give you Vibgyor. And you will observe that the bending of violet is more, because violet is having less wavelength. So the light which will have less wavelength will bend more, So bending will be less in case of red light, and bending will be more in case of violet light. Why? Because it will because it has less wavelength. The value of wavelength will be around 400 for violet, and the value of wavelength will be around 700 for red light. So you can see the refraction as well as refraction in this demonstration. Got it? So this is what we have observed in prism. Let us replace this prism with something else. We'll replace this prism by a glass slab. A glass slab. And let us try to observe the path of light through that glass slab. Yes. So this is a glass slab. Now we'll be putting this glass slab in the path of the beam, and let us try to analyze the path of the light now. You can see the incident beam, and you will be able to see the path of refracted beam. Can you show that path on the screen? Path of refracted beam is not visible to us. Please project it over the screen. Keep it straight, parallel to the slit. Keep that straight, parallel to the slit, that glass slab. Yes, yes. Now project it over the screen. Can we check that over the screen? This is a beam. This is the top view. Right. Yes, from the opposite side, from the opposite view. If you can show us the screen over which we can see the direction of this. No, it's not that visible. Let it be. We'll move ahead. We won't wait for the action. There are a lot of things to discuss. So this is what do we mean by refraction. And I want you to explore rainbow with all these phenomena. So when I talk about rainbow, When do we observe rainbow? After rains. Yes, very good. After rains, we observe rainbow. And what phenomena one observes in rainbow? What phenomena? Yes, text in the chat box. Some of you are writing refraction. Yes. What are the phenomena or phenomena? Dispersion of white light, Arnavi is writing. Refraction, Aditya is writing. Dispersion of light, Shreyasi has written. Peer Tapadia says reflection, dispersion of white light. All of you are not nearby to the answer. In rainbow, we observe all phenomena. In rainbow, we observe reflection. In rainbow, we observe refraction. In rainbow, we observe dispersion. In rainbow, we observe total internal reflection effect. Right? So read about it and make a project. Right? Make a one-page report over rainbow. Physics of rainbow. I want you to explore two things. What happens in rainbow? Second thing, why do we observe rainbow in a semicircular kind of geometry? Right? So these are two things to think upon. Let's move ahead with more enchanting phenomena. So till now we have seen scattering, reflection, refraction, total internal reflection. Now I will speak something about interference of light. Interference of light. When two light waves interact with each other, then one minute. Yes, perfect. When two light wave nature of light explains this interference of light. And because of this interference of light, we cannot observe the things which is of this wave, which is of this wave. We observe something else, and that is interference of light. You must have seen the colorful roads when some oil drops or petrol, then you will see some colors over that path. That colors you observe because of the interference of light. Interference of light. And again, the phenomena which is because of the interference of light is diffraction. Diffraction, which was explored by the scientist Grimaldi in 1835, if I'm not wrong, 1835 or 1860. Right? Diffraction, breaking of light. Breaking of light. So let us see, what do we mean by diffraction of light? I will take you to the demonstrations of diffraction of light. So let us see, what do we mean by diffraction? Yes, this is diffraction of light. Can you lit so that they can see from which source we have diffracted the light? So this is a laser light. This laser light is passing through a CD. There is one blade, and in between there is certain space. See, if someone will say that light only travels in a straight line, then the laser light is traveling through a straight line, and it is getting splitted over a horizontal range with some breaks. This phenomena could not be explained with the help of particle nature of light. This can only be explained with the wave nature of light. This phenomena is called as diffraction of light. Diffraction. Diffraction. So on the wall, you can see the diffraction pattern. You can see the breaks in the light, right? So the light gets splitted when it was passed through a slit. What do we call that as? We call that as a slit, right? So this is one of the way to get the diffraction pattern. Other way to get the diffraction pattern, so we'll replace this with some other thing. Here in this CD, you can see there is one hurdle, you can say, for light. In the first case, everything was blocked, and in this case, everything is open. There is one hurdle for the light to pass. We'll pass the laser beam through this hurdle, and we'll see the patterns which this will create on the screen. So let's see over the screen. Yes, beautiful pattern. You can see that light gets pleated horizontally again with some pattern, and this pattern is again called as diffraction pattern, and the wave nature of light can explain this diffraction pattern of light. So in higher classes, you will go through the theory, working principles and all about these phenomena of light. So this is diffraction of light. And do you know, we use smartphones, and these smartphones have screens, and these touch screens have different layers. When you will open someday, right, don't try to open your screens, but whenever you'll get the opportunity, you should see these smartphones have such layers after it, and one of the layer is the diffraction grating. What do we call diffraction grating? Grating. You can write it down. Grating. These are the gratings through which one can see diffraction pattern. So we'll show you the diffraction pattern through the layer of your mobile phone. Yes. So this is the laser beam. When we pass this laser beam through the pattern, and you can see the dots, right? So this is because of the diffraction, and the optical instrument which creates it is called as grating. Grating. In this material, there are number of grooves which is responsible for making such diffraction pattern. You can read more about the diffraction grating, right? Change the orientation of that grating, so then you will see that these dots will align themselves in vertical direction when you will change the orientation. So this is because of the phenomena diffraction. Isn't this interesting? Well, so this is about diffraction. You can explore more things about diffraction. The colors which we see on the feathers of birds, on the feathers of peacock, is because of the diffraction phenomena, because they have certain kinds of slits in between. They provide certain spaces to pass the light through it, because of which different colors appears on their wings. This is because of the phenomena of diffraction, right? Next phenomena I want to explore is polarization of light. Polarization of light. When you will deal with this term, then you can understand something about 3D movies. So in these 3D movies, the goggles provided to you are called as polarized goggles. Polarized goggles. So what is this polarization effect? I will try to explain you. As I have informed you that light consists of electromagnetic waves. It consists of electric fields and magnetic fields vibrating perpendicular to each other. So from our bulb, from our tube lights, the emissions takes place and photons goes in any direction, n number of directions. Those particles of light travels in any of the direction, in every possible direction. So when will pass those photons through these polarizers, then the photons which will come out of this will have only one possible direction of vibration of electric field. Means you won't get the photons whose electric field will vibrate like this. You will not get the photons whose electric field will vibrate like this. You will not get the photons whose electric field will vibrate like this. There will be one and only one orientation of photons whose electric field will be confined to vibrate in a single plane. So this phenomena is called as polarization of light. Whenever we do such things with the help of some optical instruments, we call that phenomena as polarization of light. What it does, the very first effect created by the polarization of light is it reduces the intensity of light. It reduces the intensity of light to half of its value. If I will be the intensity, then it will make that intensity I divided by 2. Right? This is the very first effect which is being produced because of these optical instruments. So this is polarization of light, and for this we need polarizers. The expensive goggles which we wear of Ray-Ban and all, those are polarizers. The goggles that we wear for 3D movies are polarizers, in which one of the eye permits the polarization like this, other eye permits the polarization like this. They are crossed. One will permit the polarization in this plane and other will permit the polarization in the plane perpendicular to that. Through this, one can enjoy the 3D movies these days. There are certain other technology also, right? This is polarization, and you can see there are 2 polarizers. So we'll pass the light through one polarizer. So without polarizer, try to visualize the intensity of laser beam. Yes, without polarizer. So this is laser beam without polarizer. Now pass the polarizer through it and shows the intensity. You can experience the decreased frequency. You can observe the decreased frequency of laser beam. Now what we'll do, we'll put one more polarizer after that, and we will try to rotate that other polarizer by some angle. This is what we'll try to do. So before doing this, I want you to lit up the things so that they can see what exactly we'll be doing with polarizers. Yes, lit up the things. Yes, this is polarizer in one of the hand, and in second hand we will keep other polarizer, and will rotate the other polarizer. Will rotate the first polarizer or second polarizer by some angle, and we'll try to observe the laser beam at the bottom. So let's do it. As I have said, the polarizer will allow to pass only one orientation beam, only one beam which is vibrating, which will be vibrating in some fixed plane. And when we will put some other polarizer, so it will try to block that beam completely. See the paper, see the white paper after rotating the other polarizer by some angle. You can see the reduce in the intensity, and then intensity drops down to zero. Again, increase in intensity, drops down to zero. Increase in intensity, drops down to zero. Yes. So this acts like a filter. This acts like a filter. So we can block the light completely with the application of two polarizers. And this effect was observed by the scientist Malus, and he gave a law which is called as Malus law, which you can also explore. What is Malus law, right? So many things we have explored in this lecture within 15 minutes. Now I can see the chat box is full of questions for me. I will take few of your questions, then I will take the questions later in our group, right? So I want